Hello, and welcome back. As we've discussed in the previous lectures, RDD supports two types of operations, transformations and actions. In this lecture, we'll be talking about transformations. Transformations are operations on RDDs, which will return a new RDD. Keep in mind that transformations will return a new RDD instead of mutating the existing input RDD. The two most common transformations are filter and map. The filter transformation takes in a function and returns an RDD formed by selecting those elements which pass the filter function. The filter function can be used to remove some invalid rows to clean up the input RDD or just get a subset of the input RDD based on the filter function. The map transformation takes in a function and passes each element in the input RDD through the function, with the result of the function being the new value of each element in the resulting RDD. The map transformation is versatile, that it can do a lot of things. For example, it can be used to make HTTP requests to each URL in our input RDD, or it can be used to calculate the square root of each number. It is worth noting that the return type of the map function is not necessarily the same as its input type. Take a look at the following example. We have an RDD string, and our map function was to parse the strings and return an integer, which is the length of the string. Our input RDD type would be a string RDD, and the resulting RDD would be an integer RDD. Now let's take a look at a real problem that we could solve using the Spark filter and map transformations. I'm back at our Spark tutorial project. The file we're going to analyze is some global airport data that lives in the airports.txt file under the in directory. This is a CSV format file. From left to right, each column presents the airport ID, name of the airport, main city served by the airport, country where the airport is located, IATA, FAA code, ICAO code, latitude, longitude, altitude, time zone, DST, time zone in Olsen format. Open the airports in USA problem file under the RDD airports package. The task for us is to create a Spark program to read the airport data from the airports.txt file under the in directory. Find all the airports which are located in the United States and output the airport's name and the city's name to the airports in USA text file under the out directory. The sample output would like this. Let's see how we can solve this issue. Just open up the airports in USA solution file under the same package. First, we initialize the SparkConf object. SparkConf object specifies various Spark parameters for a Spark application. Most of the time, we can create a SparkConf object with a new SparkConf method. Here, we set the application name for our Spark application. This would show in the Spark Web UI. We will see Spark Web UI in a later lecture. Then, we set the master URL of the Spark cluster. In this example, we will be running Spark in local mode, so we can specify local in the master parameter. Local 2 means this Spark job will run 2 worker threads on 2 cores of the CPU on my local box. If we set it to local star, it will be running locally on all the available cores. If we set just local, it will run locally with only 1 thread. In this way, we have constructed our SparkConf object and set the application name and master URL.
Then we can create a Spark context object by passing the SparkConf object as a constructor parameter.
As we have mentioned before, Spark context is the main entry point for Spark functionality. The Spark context represents the connection to a Spark cluster and can be used to create RDDs, accumulators, and broadcast variables on that cluster. Then we call text file method on the Spark context object to load our input file as a string RDD. Each item in the string RDD represents a line in the input airport file. Next, we need to find out all the airports which are located in the United States. So here we call the filter method on the string RDD. The filter method takes a function as an argument. The function takes a string as an argument, which represents each element in the RDD. This function returns a bool to decide whether this element should appear in the resulting RDD or not. So here we split each line using a comma delimiter. Let's take a look at how is this comma delimiter being declared. Just right-click it and go to Declaration. As you see, this comma delimiter is a regular expression which matches commas, but not commas within a double quotation. We can see there are some cities which have commas in their names, but the commas are being quoted. We shouldn't use those commas as the delimiter. We should only use commas which are outside of quotations as the delimiter to split our input lines. Let's go back to our solution file. After splitting the line, we take the fourth split, which is the country of the airport, and return the airports of which country equals the United States. Two things we need to be aware of. First, the split method returns a list of the split result. The index starts from 0. So the index of 3 means taking the fourth split. Secondly, if you look at the input file, all the countries are double quoted. So we need to add the double quotation to the United States as well. Next, let's map the filtered airport line to the airport name and city name pair as required. So again, we split the string using commas. Then take the second column, which is the name of the airport, and the third column, which is the city of the airport, and join them together with a comma. Return the join string to the map function. Lastly, we output the resulting RDD to the airports in US8 file in the output directory. Just run this application. After the computation is completed, let's go check out the out folder. We have an airport in US8 file. Since we have specified our Spark application to run on 2 worker threads, the result of each worker will output to a separate file. So we have 2 output files. We can look at those 2 files. They are the expected airport name and city name pair. Now we have solved our first Spark test using filter and map transformation. Next, it's time for you to do a practice. Let's open the airports by latitude problem file. We will still be analyzing the same input airport data. We want to find out all the airports whose latitudes are larger than 40, and output the airport name and latitude pair to a file. It's your turn. Try to implement your solution in this file. Take your time to work on this task, as this is your first Spark practice. If you get stuck, take a look at our airport in USA solution file to see how we use filter and map function. We'll take a look at the solution for this task in the next lecture.